Hey guys, today we're going to talk about the parent graphs of secant and cosecant.
That is correct. So,
Which one are we going to start with?
I think we're going to start with cosecant,
Okay.
since we start with sine normally.
Sure.
Alright guys, so if you remember, the relationship between cosecant and sine is their reciprocals of each other, right? So the best way that I've always taught my students to graph cosecant is to first graph it as if it were sine. So let's talk about what something like that would look like. So if you remember, with sine, we scaled our x-axis by pi's over 2's. I'm gonna
1/2 pi's.
There you go. 1/2 pi. So I'm gonna go to the end, call that 2 pi. Try to split that in half. Call it pi. Halfway. Pi over 2, and I know that this isn't the best way to do it, but you get a pretty decent drawing that way. Alright, so 1 pi over 2 pi, 3 pi over 2, 2 pi. Now of course the maximum value of sine, 1. The minimum value of sine, -1. Alright, so in doing this, I want to graph sine first, and I do this when I do it too sometimes, and it helps me out a lot. I'm going to graph sine x. Y equals sine x. We're actually graphing y equals cosecant of x or theta, but I'm going to graph it as sine first. So I'm going to grab this tool. We'll do it in yellow, I guess. Well, I'll do mine in green since he's doing yellow. Now remember, sine has, at the origin, it's a 0, so at midline intercept. At pi, 0 or midline intercept. And at 2 pi, 0 or midline intercept. So then, remember we had a max at pi over 2, and we had a min at 3 pi over 2. So I'm just going to kind of do this roughly like that. Now that's not beautiful, but it's pretty close. I'll tell you what I'll do. I'll fix it, make this look a little nicer here, because I don't want you guys to slam me. Mr. Matt, you can't draw better? Sine graphing that? There, that's a little bit better. Alright. So if you notice I graph sine, but I've done it with dotted lines because I really don't want sine, I want cosecant. So, Mr. Simmons, tell me about these midline intercepts.
Well, they, since they're on the x-axis, they have a y value of 0.
That's correct.
Okay. And if we take the inverse, excuse me, pardon me, the reciprocal of sine, if at pi, sine has a value of 0, then its reciprocal will be 1 over 0. Uh-oh, I'm dividing by 0. In my classroom, you'd hit the red button. So we've got a vertical asymptote at every single one of these x-intercepts.
So we have a vertical asymptote and a vertical asymptote and a vertical asymptote. So what's going on in between those vertical asymptotes?
If I take the reciprocal of 1, 1 over 1 is just 1. I don't know if I've got the same color or not. And the reciprocal of -1 is just -1. The big question is what's going on in between. Well, the smaller it is between 1 and 0, the closer it is to 0, actually the larger the reciprocal is going to be. If I have, say, 1/2, its reciprocal is 2. But if I have 1/100th, which would be a lot closer to the x-axis, its reciprocal would be 100, a much bigger value. So essentially this U shape is going to sort of flip up over the line y equals 1. And it's going to look something like that. And it's going to go up, up, up forever, the closer you get to the x-axis here. And right when you hit the x-axis, boom, your vertical asymptote. We've got the same thing going on in this portion from pi to 2 pi, except everything's negative. And it's going, well, shoot. Oh, I can't use that, can I?
I can't. I don't know if you can or not.
There. It'll look something like that.
Alright, so if you were in Miss Rowland's room, what she would say is, make the frowning faces be smiley faces, and the smiley faces be frowny faces.
That's
That's for
backwards.
us who were trying to, you know, get a little bit more basic with this thing. All right, so that is y equals cosecant of x, guys. Remember, it's reciprocal of sine. So one of the easy ways to do this would be to graph a dotted line for sine and then reciprocate everything. So let's talk about secant x, Mr. Simmons.
All right.
So y equals secant x,
Well,
and
secant
remember,
is 1 over cosine.
there you go.
So let's start with the cosine curve.
All right, sounds good to me. So I tell you what I'm going to do. I'm going to go ahead and set up my x value. I'm going to scale it by pi's over 2's. This thing is not. So 2 pi, pi over 2, and 3 pi over 2. Maximum of 1, minimum of -1. All right, so we said with cosine, at the y-axis, at the vertical axis, we have a max,
Correct.
and we stop at a max.
Correct.
Halfway in between, we have a
A minimum.
minimum, and then we have midline intercepts at our quarter points and 3/4 points. So let's see if I can't get a decent cosine wave. That'll work.
Yep.
All right, so again, we said, just like on cosecant, that when we had a 0 or a midline intercept,
Right.
when we flipped that 0, it was
A vertical asymptote.
vertical asymptote. So I'm going to go ahead and add my vertical asymptotes in here.
Yeah. Yeah.
What's going on in between these vertical asymptotes, Mr. Simmons?
Just like before. All we're doing, we're taking the reciprocal of all of these values. The closer it is to 0, the greater the value. The closer it is to 1 or -1. I can't say greater or less because one's positive, one's negative.
Yeah.
I'm being a little too technical here. But it just flips it into our U shape. And on this side, we get kind of half of 1 on each side if we limit our domain to 0 to 2 pi. But that's your parent graph for secant.
Now, you know, we keep going. This would go up here. There'd be another asymptote. Down here, another asymptote. Now, the question, though, is this. What is the period of cosecant and secant? Because it looks like, remember on tangent cotangent, we looked between the asymptotes. And we said that
That
the
was 1
period
period.
is 1 pi of tangent and cotangent. However, remember that cosecant and secant are reciprocals of sine and cosine. Sine and cosine had periods of
2 pi.
So, obviously now we're still going to have periods of 2 pi. It's just going to include 2 waves.
Oh, did it stop?
No,
No, it's the
still
battery.
recording, but the battery's about to go low. So you can either draw one period like this, or if you want to put an asymptote and continue to draw it that way, you may. This is the way I prefer to do it. So however you want to do it is fine. Just remember, we're going to graph the transformations of these coming up in class. Make sure you watch these videos, you pay attention, and you're doing your homework. Anything else, Mr. Simmons?
Say your prayers and eat your vitamins.
Every day. Have a good one. We're out of here.